Ah, math. It's so much fun. There's rules to follow, and as long as you follow those rules, you'll be okay. And in this class, we will need to do some math. And we often end up dealing with fractions. And it's good to just review how we handle fractions. So in this document that you can download from the notes page on Canvas, I just have addition, subtraction, multiplication, division, and then also some exponent information, and then some trigonometry notes. And this is not terrible. And when we run into this in class, we'll actually go through it. Uh, but first, when we first do it, we'll go through it in detail, and then as we progress in the class, we'll go through it in less and less detail. So sometimes we need to add fractions. And when we add fractions, the most important thing is that you have what's called a common denominator. Remember, the top numbers are called numerators, and the bottom number are denominators. Okay, so A and C are numerators, B and D are denominators. And what we need to have is a common denominator. We need to be able to add fractions that have the same number in the bottom part of the fraction. So I'll just write over here, for example, we cannot add like this, 1/2 plus 1/3. It doesn't work, all right, because we do not have a common denominator. We'd have to do something, excuse me, to make that common denominator. And that's what this side of the equation actually tells us. The easiest way to get a common denominator is you take that denominator of one fraction and multiply it for the numerator and the denominator of the other fraction, and then take that denominator and multiply it by the numerator and denominator of that fraction. So in essence, what we're doing is we're doing A times D over B times D plus C times B over B times D. It doesn't matter which order I write them in. That's all we're doing. And because I now have this common denominator, I can now rewrite this as AD plus CB over BD. All right. It's that simple. All right. I know it seems simple. It's easy to say. It's hard to sometimes do, but that's what you're ultimately going to do when you're trying to add two fractions. Here's the example here. 1/2 plus 3/4. If I want to add these two, I just can't add, I can't make that 4/6. That's just breaks our math rules. So what do we need to do? We need to multiply this numerator by this denominator and this denominator by this denominator. So we're multiplying, in essence, I did D over D, that in essence is 1. So really all we're doing is we're multiplying this original fraction by 1. And we're doing the same thing over here. Sorry, I did that. I should have done it the other way. B over B is multiplying C over D by 1. All right, so we're not really influencing the math at all here. So what do? I do 1 times 4, and then I would also have that intermediate step here, 2 times 4. And then I do 3 times 2. And then I would do the same thing. I would do the 3, or excuse me, the 4 times 2 in the bottom. And now I have that common denominator, which is going to be 8. And now I can make that addition of the numerator, 4 plus 6 is 10. And then I can simplify that, reduce it down to 1 1/4. Okay, so addition and subtraction are exactly the same process in terms of getting the common denominator and then adjusting the numerators appropriately. Okay, so those aren't too bad. Multiplication, super easy. All we do is when we have two fractions and we're multiplying them by each other, we multiply the numerators and we multiply the denominators. Okay, and then we get AC as the numerator and BD as the denominator. Division is nothing more than multiplication, but it's just a little different, has a little bit of a twist. We'll actually do this quite a bit in this semester. We have a fraction divided by a fraction. And what we actually do is we don't divide this, we multiply. And what we multiply is the numerator, a over b, times the inverse, d over c, of the denominator. Inverse simply means we flip these two numbers with each other. So instead of c over d, we make it d over c. And now we've got multiplication, which is exactly this rule up here, and we get ad over bc. So we'll do this quite a bit actually where we have a fraction over a fraction, all right? And sometimes a fraction may be like 2 over 1/4. You say, well, where's the fraction in the numerator? Well, really what we have is 2 over 1 divided by 1 over 4. And then we would just take the numerator times the inverse of the denominator, and that's 8 over 1, or 8. Okay, so we'll actually see this process quite a bit when we deal with some of our equations where we have a fraction over a fraction. All right, so this one's probably pretty important to make sure you understand. Multiplication, super easy, just numerator times numerator. Addition and subtraction, the key is finding that common denominator. And to get that, you just multiply the two denominators by each other and then adjust the numerator accordingly. All right, exponents. Exponents are, if you can't read that, it looks so small, this little superscript next to variable. And all this is going to tell us is how many times this number is multiplied by itself. So a squared is a times a. If we did a cubed, now here it is, a cubed, a times a times a, it's multiplied 3 times. If we do a raised to the 1/2 power, that's a little different. There we take the square root of a. So if we do 4 raised to the 1/2 power, that actually is the square root of 4, which is 2. So anytime we see a fraction as an exponent, it's just a funny rule that we have to remember that that actually is going to reduce this number in some way. And so a lot of times we may we may get to a point where we raise to something other than a square root. And if we do like a to the 1/4, we actually do this reduction of 4 here instead of, this would actually be a 2 at that point. So we're taking, we're reducing that 4 that way. And so now, another one that we will actually use quite a bit is this one right here. A raised to the negative b. Let me write that bigger so you can see it. A raised to the negative b. When we see a negative in the exponent, what that actually means is that this is a fraction. So we do a raised to the b power, but that's in a denominator. So for example, we often will write velocity as meters times seconds raised to the -1. And when we write that, we're actually writing meters per second, because that -1 is applied only to the s, seconds in this case, and that means that that s is in the denominator. All right, so you'll see this notation for speed often, or this notation, but typically in manuscripts and in text, we'll write it this way because it's a little easier to write it that way. Okay, and then the last thing that's just good to review, we'll do some of this throughout the semester. There will be times where we will need to do vector math, and vector math often breaks down to just trigonometry. And we need to know Pythagorean theorem, a squared plus b squared equals c squared, and that refers to a right triangle, where a right triangle has one of the angles that's 90 degrees. A and B are the sides of the angle, or excuse me, triangle, and C is the hypotenuse. And then this should be theta. All right, and that's the angle that we're dealing with. So when we want to know the angle, we actually need to know our trigonometry functions that you have a calculator for on your phone, on a computer, Excel, what have you. So these are good just to have in your back pocket when we get to dealing with some vectors, and we'll go through this a little bit more. Sine, we just take the ratio of the opposite side over the hypotenuse. Cosine, we take the ratio of the adjacent side to the angle over the hypotenuse. And tangent, we take the length of the side across from opposite the angle over the adjacent side, the side next to it, and we don't involve the hypotenuse. So there's just different ways to rewrite some of these parameters too, in terms of trigonometry notation. All right, so just some little math review and some fractions. Division is going to be very important. Understanding this -1 is going to be important, and a little bit of trigonometry. Okay, thank you.